make simulations of large networks on big Linux machines easily. Above the BIOS, there's some native implemented communication stacks. These are only the core parts of the communication stacks. Some parts of the communication stacks are actually implemented in Java. And on the top, there's sitting the Ambicomp virtual machine, which is executing the Java programs. Okay, I now want to elaborate a little bit more about the single system illusion and how you can think about what it's like to program a system which is providing a single system illusion. If you don't have a system which is providing a single system illusion, you have to ask yourself the following questions when you're writing applications. The first one is, which resources are available in my network? So I want to use some resources with my applications, some sensors or some actuators, and I have to know where they are located. And I have to know how I can reach them. The next point is how do I want to structure my application? Because if I take the application apart into some modules and want to execute these modules on maybe different nodes, I have to make clear cuts between them and combine them with some communication channel. So the next step is to reason about which communication channel do I want to use. And with that question comes the next question, which protocols do I want to use to let my modules exchange information. With a single system illusion, this picture is a lot different. At first, it hides distributedness completely. So the only thing which is left from distributedness is you have multiple threads executing. And these threads have to exchange information, and they can do that over function calls or reference passing. Something you can use directly in the language. And the next thing is that it shifts communication from explicit communication, where I have to write code that sends messages and receives messages, and does something with the content of the message, to just passing that information over parameters or function calls, for example. Another nice thing of a single system illusion is that it adapts to changes in the network. So when nodes leave and join the network, you get fewer or more resources and can use them immediately if you have some mechanism to find them. What the Ambicomp virtual machine now does is we implemented a global heap. The global heap is shared over all instances of the Ambicomp virtual machine. That means that on every sandwich module where you have enough RAM, there is some part of this RAM reserved for objects that are reachable from other nodes. And by other nodes, I do not only mean other stacks like that AIQs I showed you before, but also other sandwich modules. So the single system illusion isn't only achieved over the multitude of nodes, but also inside each node, when it consists of multiple sandwich modules. Okay, and last but not least, the communication is, as I already said, achieved via passing information about over global accessible objects in that heap. Okay, what can be global accessible objects? It's a little bit irritating because you may call plain old Java objects only, but we do that a little bit different. We also are telling code and Java arrays and execution frames objects. So all these kind of objects can reside in the heap, and be accessible from remote nodes. The left part of object types here, code and static fields of objects, can be found via asking an instance of the distributed hash table, or let's say Oracle. You ask somebody where is this object located, and the Oracle somehow knows where it is and can give you an answer. And with that answer you also get a reference, and this reference is pointing to the object and is unique. The other kind of objects here on the right side are also accessible via reference, but you already have to have access to that reference before. So the initial references you get from the left parts, so mainly from static fields, and the right ones you get by passing them around and getting them during the lifetime of the application. To make it more clear, just a little application example. Yes?
So this is essentially shared data, but when I have those global objects, but when I have multiple threads or communication going around, how do you protect it from being modified by two threads at the same time? So is there some way to clear that? How do you handle that?
The synchronization problem has to be solved. We are trying to do this by using techniques from software transactional memory. So we're just trying to provide the application developer with some syntax to annotate atomic blocks, and the shared transactional memory paradigm assures you that these get executed, and if a failure happens, there's a rollback. Okay. The application example. It's very simple. We have two measurement applications. These can be the same. You can think of compiling one application and deploying it on two nodes. I2A and I2B are the two nodes. And the second node also displays some code to drive a display and display some temperature values. What you now only have to care about is the temperature data store object, which has to reside somewhere in the global heap. You don't know where it has to be located. You only have to know how I can get a reference. So initially, you can think of implementing this temperature